But to me, I don't normally eat the fried one. Only eat inside of it, not outside. Okay. Yeah. You're going to see this one at your book. It started with something like this. The filtration, when the filtration started, when you look at the some pictures in the tomb, murals, this one is around 1900 BC in Tibet. But right hand side, this is the quite famous drawing. They are actually making sake. The making sake, there are several processes of filtration associated with it. Even though a lot of people they are doing it, they actually squeeze the fermented rice, making sake. So, in fact, the filtration started BC probably more than 3,000 years ago. So, filtration has been around for a long time. One thing I can tell you one thing. In the Bible, God created earth. He created several substances, day and night, and human as well, and then something. There are some separation and filtration are already there when you create something. The water and earth is a separation. So separation actually started from way back when the creation of earth and human beings. Separation and filtration has been around really long time. That's what it is. This is what I told you earlier. The Fuji Mountain. Fuji Mountain, around that area, there are a lot of tasty water. You can get it from. How? How come? This is what it is. Fuji Mountain. And inside looks like a river, kind of. And then there are some sand coming out. Some of them are going into the sea. Some of them are you can actually drink. So sometimes it takes more than 100 years from starting point to the where the drinking water foundation coming out of drinking water foundation. So that's where sand filtration started. This is what the Professor Iritani started on his work. That's why I like it. But he didn't improve his work. Also, he didn't use Darcy's law. He used his own resistance kind of studied with. So you will see the book, but the book is really good. It's easy to understand. The other thing is there are a bunch of drawings, pictures there. That's what I like. So when you have time, it's not that difficult. The equation itself is not that difficult to understand. there are some integration in it, but that's all. So I recommend to read that book. It's only less than 100 pages. So that will help you to understand liquid filtration basics. Do you have a copy of it? Electronic copy of it? Not yet? Not yet. So actually, that book started something like this. In fact, I really wanted to use that book for tutorial 2. But since you don't have it, that's why I made a couple of slides. Okay, here. Professor Mukherjee, he covered something, but I'm the person who actually did some experiment. So it's comparison between air filtration and liquid filtration. There are so many similarities. That's what I like to say something about. Here, the less than 1,000 nanometer, 1 micron, then interception, and what about the 0.3 down, then diffusion, electrostatic effect. This is basically for air, so airstream, something like this. Then, well, the source is right here. Filtration in electrified filter medium and electrostatic depression. Well, yeah, and then this is the air filter, particle capture in the air filter. What about the particle deposition mechanism in liquid? The difference, look at the difference. But surprisingly, we can apply some of the mechanism to the liquid filtration. Hydrodynamic interception for particle having radius greater than distance below the flow string, which carries particle and surface collecting grain in the bed. Suspended particle will be intercepted by surface and collected. This concept is really same as the air filtration. Also, diffusion and deposition in liquid suspension, small particle less than 1 micrometer surface. In this case, diffusion can cause random of particle, which is control rate of particle deposition in the liquid bed. So this stays the same. Electrostatic interaction. This effect is a lot less in the liquid, that's for sure. And straining and sedimentation should be considered a deposition mechanism for larger particles with high density. The other, the electrical double layer repulsion, van der Waals force, are important for collecting small particles. Actually, this one is stay in the air filtration as a liquid filter too. Oh, what?
No, sir, I am not asking you. You are just relaxing my mouth.
This is quite interesting. Huh?
Yes, sir.
Okay. Is that okay? That, yeah.
Yes.
Okay. Surprisingly, in the liquid, the dendrite formation is occurring. So this is normally, air is normal, the phenomena, dendrite formation is. But however, in liquid, somebody did research on it. It's the same thing. It's dendrite formation. As long as the liquid flow rate is slow, not so in depth filtration, particle diffusion, normally in dendrite form, this is exactly same as air filtration. It occurs in liquid as well. So most of the particle will be collected by web formed by various capture particles. Initially, the filter efficiency increased with time due to this dendrite formation. So there are some breakthrough, which means it's not going to stay long. It drop out, not like air filtration. So this one we already covered that one. But important thing is, whatever the air filtration mechanism, it can be applied in the liquid as well. That's key message. We already covered that one. Cake filtration, depth filtration, surface filtration, and cross-flow filtration as well. So you can read through it, this one. And cake filtration, depth filtration. We actually covered this one a lot. So cross-flow. Yeah, cross-flow is quite important part of it. The Professor Mukade, I don't know, I actually pronounce his name. Mukopade. Why the last spelling HYH is there? I'm not wondering. Thai.
Yeah, DHYAY. It's not the, it's, or you can say Mukherjee.
Okay, nowadays, if I have the grandkids, sometimes they ask me to make some the names of it. So I actually create one for my granddaughter. Her name is Isla, but Isla. So Isla. See here, pronunciation a lot easier. Isla. Mukopade. I don't know. Don't talk to him. Yeah, surface filtration, cross-flow filtration. And in fact, the upper part of the drawing, I got it from the book, the Iritanes book. So, I think the drawing he presented is really close to this one, the depth filtration and particle capture, collecting media. Then why you have to use filter aid? Try to avoid the particle collection on the filter media. So That's why you need to use the filter A. Well, this one we already discussed previously. Surface filtration and depth filtration, and cross filtration. I got all the drawings from your book. Yeah, no. The book you're gonna have it, yes. So if it is cross flow filtration, somehow you have to that pulsing is quite important to remove the particles on the membrane material. The straining, actually straining is a key mechanism for the liquid filtration. And straining, again, larger particle, then the filter medium opening up removed. In K filtration, same thing. Right here, you block the holes. So in order to prevent the high pressure drop, that's why we need to use the filter aid. Diatomaceous earth is really popular filter aid. However, recently they found out that material is carcinogenic. So the handling is a big issue. That works really good. But recently found out that is carcinogenic material. That's quite important one. But when the Iritani wrote, actually he did not write the book. His student write the book. It's not write the book, it's a manuscript, something like this. But in fact, I'm the first person making English version of it. But I'm going to add, and then add a lot of other material into MBR as well. I don't know how long it takes. I hope in 3 months or so. The issue is currently he is preparing for our testing equipment, filter testing equipment. So depth filtration, adhesion, electrostatic force, and inertia, interception, straining. Here look at interception, inertia, and diffusion. That's so-called most likely in the air filtration mechanism. Cross flow, we already know. Cake filtration. Okay, compressibility is quite important one. I don't know whether I have Cousin and Carlson equation here. That's right there. Right here. That's the end of it. Right there. No. That's fine. Yeah. This one S is the Kozeni constant there, but it's more likely the Darcy's equation. But actually, the Kozeni Kalman, they actually consider big particle as well as small particle relationship between. Yeah, the surface depth K, discretion is there, and media used and common application. Can you bring the sound a little lower?
No, sound
Lower.
Is it okay, sir?
Yeah. Oh, yeah. I think it is better. I hope. So, pressure filtration, oil purification, further processing, and K filtration, centrifugal. This one, pre-cut filtration. That's what I like to look at it. This one. Yeah. Pre-coating is process of applying a thin layer of filter material, such as this one is issue actually, diatomaceous earth. This is really popular. A lot of the people, they are still using it. But important thing is, this is carcinogenic material they found out recently. So when you're handling, then you need to be careful. Yeah, I brought some of the samples, cellulose, rice, you'll see later on. So how is it working? I'm recording. This is what it is. Filter A is right there. Filter A. That's why it actually avoids blocking of particle. That's what it is. The centrifugal using perforated basket with the filter cloth outside. The same principle. And perforated basket, filter cloth, mechanism, and filter system, discharge system. I'm going to use this one. So, key component of centrifugal filtration, perforated basket, and cylindrical metal, and cloth inside, and driven mechanism, rotation, certainly. Feed into the slurry into the basket, discharge system. The advantage, fast separation, for large volume continuous, can handle abrasive or crystalline solid and relative dry cake formation. And the limitation is not suitable for very fine and incompressible solid. Cross need a regular cleaning, certainly. So the trouble is the cost of equipment very high. Where is the application? Where are the sugar industry, pharmaceutical, and chemical process? I already showed you this one. But this is my last slide. This is gonna be. I actually shipped this one to the Dr. Mukhopadhyay, but he had hard time go through custom and the immigration because I separated into two pieces because it I'll show you. I'll show you. Actually, this one I use a lot when I do some the filtration research. It's small, but it's really good for liquid filtration testing. See, this is the you can put any type of media right here and close it like that. Also, there are packing material here. There's no bypass at all. I bought it 30 years ago. At that time, it was $1,000. Right now, I don't think you can buy it. If it is available, probably it will be about 3,000 or more. Also, this is made out of the stainless steel, but lab purpose, you like to see inside the solution. So the flex glass is not bad, but you cannot apply a lot of pressure. That is another issue. But this is small one, but it's really handy. That's why I sent some drawings here. Oh, where is it? Hey. Okay, would you please open up the one?
This one or
No. Go back to the media design. Media design. Media design.
Designing filter media.
Yeah, that's it. And open up. And then go down further.
This one, sir?
Yes, look at that. Yeah. Exactly the same picture, this one. But important thing is the theory behind it. No. Up. Right here. Oh. This one. Okay, here. This is the basic equation you're going to use today. So, engineering mechanics, important thing is stress-strain relationship. Then we heard about a lot. Then how actually you can get stress and strain. That's what you're going to do today. Using this equipment. The theory behind is right there. Okay, here. This is stress. Delta P, that is, you're going to measure the pressure. R, diameter of this capillary. Okay? Only this capillary. Diameter of this is 5 millimeter. 5 millimeter. I want you to write down. It's not diameter. You have to use radius, 2.5, but it's 5 millimeter. What about length? Length is 79 millimeter. Length. Oh, I have to check whether 79 or 78. It doesn't really matter. Yeah, 79. I don't know whether you can see it or not. This is drawing along with this one. Here, this piece is filtration section only. This is making slurry, and then you wanna inject that slurry right here. How? And then, oh, the other side, like this. Exactly the same amount of solution inside. And put it there, like this. And then you have to insert filter media right here. And close it. And then you have to use air pressure. And in fact, you have to measure the exact pressure. Then somehow you have to measure the timing. Goes through all the liquid out. But basically, here, Q, you're going to measure it. And then P, of course, you know. So once you know the pressure, and R, we already know. We already know the length. Then you can get stress right there. You can get stress. And then what about strain? How are you going to get it? Here is the volumetric flow rate. So you actually get the weight. You don't need this, right? Okay. So once you obtain the Q, then everything is already you have. So you have strain rate. It's not strain, it's strain rate. So then what is viscosity? How you want to measure the viscosity? Use Newtonian flow equation right there. You have strain rate, you have stress, then you can obtain viscosity. So today we're going to use water. So you have to find out whether your answer is 1 or not. It's a quite interesting one. So the originally, this one actually I like to make, well, I want them to make something like this, so that we can use different slurry and then test the constant pressure experiment, constant rate and variable rate, something like that. That was the original plan, but it didn't work. But it's a lot better because use this equation, to understand strain rate and stress, in order to get viscosity down. So I believe it's going to be fun. A fun experiment.
Sir, Q is the flow rate, is it?
Huh?
The Q?
Q, yes, mass flow rate, yes. Flow rate, yes. So you have the balance and then stopwatch, so you can get it. Okay. So looks like it's quite simple task, but basically it's quite important as far as engineering principle, understanding engineering principle. So I hope you can enjoy. See, I use that equipment a lot when I working with the Cummins diesel engine company. This is small one, but you don't have to use a lot of liquid there. That is better. Huh?
accuracy level will be?
Every experimental procedure, you have a lot of error. Yeah? So how you're gonna get it? Repetition, 10 repetition, something like that. It's an average. So Ajay and myself, we spend a lot of time to prepare something like this. See, whenever I have some invited lecture, something like this, I always emphasize experiment, experiment.
That's actual learning.
Yeah, the hands-on experiment is quite important to understand the principle. So this is actually design of that one, and then I really want them to make something like this. I wrote the instruction up there.
Okay, so who has developed this?
Huh?
You have developed this?
Yeah, I want them to develop it here. So I thought, I don't know whether they can prepare it in time. That's why I brought my own stuff. Actually, Jose, he spent a lot of time. The starting equation, the phi delta p r 4 times, and then AQL, that's the famous formula. It's okay. Now we can do it. Are you going to demonstrate, or some of them come here and do the experiment?
How much pressure we should use?
That's minimum, but you have to read through it. I don't know whether you can read. Yeah, 2 is good enough. 2 is good.
Have to use sand also.
Huh?
Have to mix the sand also. Sand.
Huh? Sand, I don't know whether it's necessary.
So then it will not block the water, only water.
Whatever you like to do, go ahead. Sand, probably. Did you bring?
Yeah, I have.
Yeah, why don't you do it?
We have two types of sand. This will make slurry, and this is a larger, bigger one.
I think that's okay. This
For
one,
cake formation.
yes. Do you have copy of the paper?
Sir, yes, sir, we have.
Okay.
Yes.
If you look at the pore and permeability, the equation 11 is over there. We are using equation 11, so-called Hagen-Poiseuille's equation. Hagen-Poiseuille's equation.
Yes, sir.
Huh?
Which one? Yeah, this one, no?
Correct.
Yeah, this one, this one.
But Hagen-Poiseuille's equation is 11.
11. Okay,
Yeah.
okay, yes, sir.
Uh, the fluid mechanics.
V is what?
Huh?
V? The, V is
Okay,
reduced.
V instead of we are using Q instead.
Okay.
So I hope you could go back to your place and then try to make something like this.
Sir?
No, you have to hold.
No. But we are taking the
Okay.
this filter is not blocking anymore.
Yeah. From now on, you are the instructor. You have to tell them, okay, what to do. Okay. Understand? Or do you want me to say something? Well, yeah, he need assistance. Anyone come out and help him out. So if you really like to do experiment, then somehow you have to know viscosity of liquid you are going to use. That's quite important. Also, once you obtain the viscosity is function of shear rate, which means the rate is faster. Normally, what happens? Viscosity drops. So liquid filtration, temperature is important, but viscosity is more important parameter. So this experiment will help you to understand viscosity value. Yeah, you don't have to sit down there. Come out so that you can have some your own hands-on experiment. Probably I need to make group. Once they finish it, then the other group come up with the experiment. So 5 of them, over there. Yes. And then 1, 2, 3, 4, 5, and the other 5. Wow. Ah, right here. Maybe 6 over there. Okay. One of them don't have my name on it. This one, I don't see my name.
Okay. Yes, sir. Your name is not good. In tutorial also I need your signature.
I think today I did.
Tutorial 2 date 17.
Ah,
So every time I am taking the signature.
oh, I
लेक्चर कर रहा है वहाँ तो बोल ही नहीं रहा कुछ, वो शांति ले रहा है।
Somebody check the timing. Timing start and end. Yeah, how many seconds?
About 1 second.
Uh, well, somebody need to check. Ah. Jose, somebody check the timing. Still you have to check the timing. Let's say it's 1 second. Huh? Yeah, 1 second is fine. 1 second is fine. Yeah. If it is already set up, then you don't know what the problem is.
We will try in bigger one.
Now we're gonna use the bigger setup. Do you know that the mass Mass.
Same.
The mass. How much?
It's 1200 ml.
Are you sure?
Yeah, you should check it.
Okay. What about weight?
What is happening?
We are doing experiment. Big one and small one. Wow, that's good. The pressure is quite low.
Small one is completed.
Yeah.
Huh?
So quick. It's so quick.
Okay.
Less than a second.
Now what we are measuring? Volume of
Volume. Volume flow rate. That's what we are. A lot better than a small one. But pressure. Here. Look, the pressure is so low. Ah. Golly. About 18. 18, 1 8.
18 years.
Yeah.
Is there easy climbing in US? Because in India there is custom it's not very costly.
I understand the Indiana,
Indian government is
Indiana,
planning.
Indiana is a big plant.
Okay.
Whole community is for coming.
Okay.
Yeah, the city is big. Also, the plant side is huge. Yeah. So they call it campus.
My question is there petrol blending is happening in US?
That's of course. That,
How much?
I didn't check it.
Because the Indian government is right now they are doing 20% ethanol and 80% blending, and that's commercially available, and they are now planning for
Is
diesel
that
also.
for coolant application?
Yeah, coolant application.
Coolant application, isopropyl.
Also became Indian government is not test commercially of it. They are planning with 10% of
Oh, I
diesel with
see.
also became.
Uh-huh.
My question is there any blending in US for diesel and petrol also? Diesel?
Diesel engine, I'm not sure whether they use the 4010 or not, but I didn't pay attention to it, so I don't know. I don't know.
My company has once exported a fuel filter.
What is product?
Diesel filters. Diesel filters.
Diesel filter,
Used in
what?
trucks.
Fuel or hydraulic oil or
Hydraulic oil.
hydraulic
So
oil.
my company manufactures all the filters.
Uh, hydraulic filter?
Not specific hydraulic filters. We mostly deal in oil refineries.
Oh,
With
oil
oil
refinery,
refineries
I
like
see.
Japan factory.
Mm.
And supply filters to them.
Ah,
It does with housing and with the oil.
I
Carpet
see.
filters and back filters, and then we have a split for that.
Mm. So how long have you been working with them?
Around 2 years.
Oh, so you are a new engineer then?
No, sir, I am not an engineer. My background is of commerce.
What?
My background is of commerce. I am a commerce student.
Oh,
I did my MBA from my home college.
ah,
The business head management
ah,
and
ah,
all the knowledge that I can
yeah, yeah. This is important.
very important.
Yes.
Most of the filter element that you are talking about, we manufacture
Ah,
non-woven filters.
बाहर होगी तभी उसको सपोर्ट करेंगे इसके बाहर होगी तभी सपोर्ट करेंगे अदरवाइज तो नीचे ये उसको पेट के ऊपर ले जाओ और जाली है यहाँ पे बाहर निकाल के दो चार और डालो वाला काम सुनते हैं
फिल्टर ही लगा थल्लो
एक बार और करें असल में ना नाम प्रेशर चलता है कुछ टाइम लगेगा रहना हमारा अब तो जग गया नहीं कुछ टाइम मारना बात है
देखो तो उसी देखो हाँ अच्छा लाइव स्ट्रीमिंग लाइव भी दिखा दो अच्छा जो इंडस्ट्रियल विजिट है इधर रिकॉर्ड करना होगा तो कर लेंगे नहीं नो अलाउड नहीं है फोटोग्राफी आप ग्रुप फोटोग्राफ से करना ना कि एंट्री करते हुए तो दिखाई सकते किसी भी किसी को ट्रबल में डालना आप इतना करना ना कि अंदर के बाहर आप क्या करते हैं ना आप मेरे साथ गाड़ी में जाना और सारे लोगों को जाते हुए आज जब हम निकलेंगे ही करके बस में बैठते हुए बस को बस लेके जाएंगे तो बस से उतर के जाते हुए और कोई भी लाइव और फिर जैसे हम लोग आएंगे बस चाहिए ले जाएंगे देखो वहाँ करेंगे क्या मैं तो जाऊँगा अब वहाँ मेरा एक थोड़ा सा हमें दिखा दे आप नाम से बस कर रहे हाँ आप ही लोग बता दें और फिर कहीं बैठ के कोई हॉल में थक जाएगा तो लाइव स्ट्रीम मैं दिखा रहा हूँ मैं भेजा हुआ सवेरा में आया यार कितने लोग कल रात से नहीं आ गए जब आपके लाइव स्ट्रीमिंग होना
You have idea what to do?
आज का लाइव स्ट्रीमिंग क्या है
I don't know.
उनको भेजोगे ना तो मैं दिखाऊँ मिनिस्ट्री को भेजूँगा आज वाला मेरे को भेज दो यहाँ मैं कोई नहीं हाँ डेट वाला आया हुआ है डेट टू का tested for this credit certificate. So you will be just to appear in exam. Suppose you are not getting any credit certificate, अब वो क्रेडिट वाला सर्टिफिकेट नहीं चाहिए तो आपको कोई नो नेसेसिटी टू appear in exam. So kindly give a consent. Appeared in examination. देख लो साइन करना. तुम क्रेडिट वाला चाहते हो तुम बताओ तो लिखो क्रेडिट appeared in examination. अब जिसको क्रेडिट में नहीं जैसे वेरका है इनको क्या जरूरत है क्रेडिट को.
जरूरत तो हमें भी नहीं है सर.
कर लो छोड़ दो. उनका सर्टिफिकेट तो दे ही रहे हैं. स्टूडेंट्स जो देख लो जैसा अच्छा है.
एकेडमिक में बेनिफिट है बाकी तो
एकेडमिक में है उसको
वैसे सर अब अगर कैश के लिए चाहिए नहीं तो वैसे लगा
सर्टिफिकेट तो मिल जाएगा. सर तो कैश के लिए कोई क्रेडिट की जरूरत नहीं है. आपका
टाइम दीजिए वो मेरे को मिलेंगे सारा कुछ निकाल दिया सब ग्रीन में
BIS तो यहाँ हजारों लोग कर रहे हैं. 40-50-100 प्रोजेक्ट
Actually, we have tried to find out the viscosity, but it doesn't matter. So
Delta P you know, R you know,
uh-huh.
L is the thickness, Q.
No. L is length. Length. Oh, where is the other?
Length of
The other piece. Yeah, the length of capillary.
what is the equation? Basic equation. That is based on Poisson's.
Huh?
Poisson's equation.
This equation is Hagen-Poiseuille equation. Hagen-Poiseuille equation.
Go back to that.
So you gave up?
Calculate the flow rate.
Huh?
Flow rate.
Flow rate is quite low, about 10 seconds or so.
No. From this method.
Ah.
We have calculated. हजार ml at pressure of 1 bar.